15 May LeetCode question, longest unequal adjacent group subsequences part 1. So basically we are given two things, words and groups. Words is an array of characters and groups is an array of numbers that are either 0 or 1. So basically it is saying that each character has a group. Each character either belongs to group 0 or group 1. So here this means E belongs to group 0, A belongs to group 0 and B belongs to group 1. So what they're asking is that you have to return the longest possible subsequences where two adjacent elements in the subsequence should not belong to the same group. For example, here you cannot write EA in a subsequence because they belong to the same group 0. You can write EB because they are from different group. You can write AB, they are also from different group. So basically if you don't know subsequences, so that is, you cannot change the relative order of the characters, but you can delete characters in between. So EB is a valid subsequence, right? But you cannot write like BE, that is not a valid subsequence. Okay, so that is how it is. And this is the brute force approach. We're not going to actually do this, but this is just for your understanding that this can also be accepted as brute force because the constraints are so less. So we have initialized a result string. We are literally traversing through each character, and we are maintaining a temp character in order to maintain our current largest subsequence that is possible. So I'm pushing the current character in the temp. Now this is the group. We are defining the group so that we can alternate in groups. So then you traverse till the end from the current character, right? And you check if the group is alternating, then you add that letter or character into the temp, and then you alternate the group basically. So, and whenever the size of the temporary is more than our result size, we update our result with temp, and then in the end we return the result. But this approach is useful if you want to generate all possible groups, right, of such subsequences. But here we are asked only to generate longest one. So here greedy approach will work, which will take off n time complexity and of 1 for our calculations. Of course we have to store our answer, so that is why I've written of n, but that is just to return. We are not using it to calculate anything. So here suppose another example, we are given words and groups, right? So what greedy says that you only do one time. You only start with the first character and you only loop through all the characters one time, and whenever you encounter the first alternating element, you insert it into your subsequence, and that will be the most optimal solution. For example, here I start with A, so A is inserted, then B, this is alternating group, so that's why I inserted B. This is C, this is same group, so skip. D alternating, added. E alternating, added. So this is our subsequence. This will be most optimal. Why so? Because the further you go from this, for example, suppose in this brute force we are starting with A, we got this in the first trial in the brute force also, but we are also checking for B, C, D, E, right? But if you look carefully, if you start from B, what will you get? The maximum B, D, and then E, right? So the further you go away from the first index, the smaller and smaller subsequences you will get as your answer, right? We are only asked the longest, so it doesn't make any sense. There is no possible way, right, to get the longer than this, right? The index 0. So there is no possible way. If you start at index 1, you cannot get a longer subsequence than you have started at index 0. So that is why the greedy approach works here. And here is the code for simple greedy approach, right? Here I have same result array, and if the word is empty, I'm just returning back because here I'm accessing the 0th element, so I won't be able to if it is empty. So that is why this condition is required. And then I have initialized with the first, and then I'm traversing with the second character to the end. And the same logic, if the group is alternating, we add it, right, and we return the result. This will always work. Let's try to submit this, right? And you will get the code in the GitHub link in the description. All right, thank you.